All right, Inequality Applications Part 2. We'll pick back up here with averages. So in this case, the question asks, you guys who know me know that I like to find out what am I looking for. What must the high temperature be today in order for the 3-day period to be no more than 100? So X is today's temperature. That's what I'm going to call it. Today's high temperature, of course. So the last 2 days, it was 102 and 105 plus the X. And then since they're doing average, we would be adding those three together, then dividing that sum by 3. And no more than 100 means we want it to be less than or equal to 100. So we haven't had equations that really set up like this. I'm going to do two things at once. First thing I'm going to do is get rid of that fraction, which is easy enough. All we're going to do is multiply both sides by 3. So that's gone, right? And then this becomes 300. Now, before I write the other part down, I can go ahead and combine like terms, which basically means add the 102 and the 105 in this case. So I have 207 plus X needs to be less than or equal to 300. When I take away 207, I find out that for today's, for the 3-day average to be no more than 100, today's high temperature needs to be 93 degrees or less. Okay? So 93 degrees or less. So it doesn't have to just be 93. If it's 89, that's cool. But if it's like 95, the average is going to be too high. So this maybe is more applicable for, say, Arizona, not Indiana. But we have had some heat waves in the summer, though. All right, so next up. Okay, for this page, it does say homework number 5 at the top. And so I'm going to help you get these set up. And then after they're set up, then the expectation would be that you would finish solving them. All right, so it's very similar to what I would do in class, with a little input from people in class. I am not going to use S, though, because it just looks dangerously like my 5. So I'm going to use X instead. So cost for each hairstyle. So this is going to get an X. The $500 is just one time, not for every hairstyle, thank goodness. And then this is how much money she charges it. This is what she earns. This is her revenue. So the 60X, the money from the hairstyles, needs to be greater than the cost for each hairstyle plus the cost for her rent. And then again, if this does not come out nicely, or however it comes out, you need to go up, because we need it to be greater than that number is the minimum amount that she would have to give to make. And the profit on the first one over is not much, because she's going to spend a lot just to pay that $500. All right, so here we have, in this case, she wants to make at least $195, and this is, X is hours. And at least 195 means it's okay to make greater than or equal to 195. So it's okay if she goes over. So she gets $8.50 an hour and a $25 bonus. So that one makes a nice two-step inequality. And because it has the or equal, if it comes out nice and neatly, you do not need to round it, like bump it up or anything, because it can be equal to that number. We still use the greater than equal to sign because it's okay if she works more hours than that. That would mean she made at least $195. That leaves it open that she could make a higher amount. All right, so those two are set up. Scroll down to these next two. So the 23 here is actually the course number, all right? So this is the course number, not a number that we use in the problem. So we're talking about 3 tests, and she wants to have at least a 90 average, so this is an average. So we don't know what her third test, that's going to be our x. The x is the third test. She got an 85 and an 89. We don't want to average them by themselves. So 85, 89 plus the mystery, we don't know what she got. When we divide all 3 of those by 3, we want at least, so greater than or equal to 90. So yes, you will multiply by 3 first, which basically tells us that she needs at least 270 total points. This next one is very similar, also talking about test scores. This is a small Algebra 1 class of 5 students. We are anticipated to have many more than 5. Not a big class like in traditional school, but more like probably 15. But anyway, so a pizza party, if the class average was 92%, that should say, I'm sorry, or higher, not of higher. So we don't know the score of the 5th student. Maybe they were absent that day. So X is the 5th student. And so the first 4 students earned an 86, a 91, a 98, somebody's rocking it, an 85, and then plus X. And then remember, we're averaging it, so we would want to take all that, and we won't divide by 4, we'll divide by 5, because including the X, there would be 5 total scores. And then we want that, might need to make a little space over here, we want that to be greater than or equal to 92. So yes, you're going to multiply both sides by 5, add up those test scores that you know about, very much like the temperature problem, just more things to add in this case. All right, so next up we have an elevator. There is an elevator in the Noblesville Excel building because we're in the Ivy Tech building, but it is so far of a walk, it's almost more trouble to get to the elevator than to hustle up those stairs. So in this case, this elevator has a maximum capacity of 1,000 pounds. So remember, maximum means we need to stay under or equal to that number. So we know something's going to be less than or equal to 1,000. And we are looking for the amount the 6th person can weigh. So that's what my X is going to be, that 6th person. So far on the elevator, I have a person who is 146, 180, 130, 262, 135, and I made this a little too big, and then plus the 6th person getting on, and all of that together needs to be less than or equal to 1,000. Were you tempted to divide by 6? We're not averaging their weight, right? Just the total of their weight. So we do not divide by 6 here. So we basically just need to add up all those numbers on the left, subtract that from 1,000, and that's how much that last person can weigh. I might just take the stairs. All right, last one. Mr. Tyler took his son to the arcade, gave him some money, and so Darius is his son in this case, and we're trying to find the greatest number of games that he can play with the money he has left, because he used some of the money for snacks. All right, and so again, we're writing an inequality, not an equation. So X here is going to represent games. And so at this point, each game is 75 cents. We have a $20 budget, right? That's the total that we're allowed to spend. We need to stay less than or equal to that $20. You can put 0.00, but since they're zeros, we don't have to. But he's already spent $6.50 of his money. So the money spent on games plus the money spent on snacks has to stay under or equal to the $20. Those are like his cost, and the 20 is like his revenue. Okay, I think in this case, this might come out nice and evenly, maybe. If it doesn't come out evenly, remember you would need to round down because it says X is less. Now, since it has the equal, if it comes out equal, you just leave it alone. All right, thank you so much. Next up, we have a review and then a quiz.